September 12th, 2025. Astronomers scanning the night sky witnessed something extraordinary. A massive object is approaching from deep space, its tail stretching across the darkness, appearing 5 times larger than the full moon and far exceeding anything seen before, even Oumuamua. Shortly after a second object is detected, both are racing toward the sun and will pass close to it only weeks apart, yet they approach from opposite directions. Experts insist that the chances of such an event happening naturally are almost zero. The official explanation is that they are simply comets, but their appearance suggests something more deliberate. Now, an even larger and more enigmatic object is entering our solar system with an unknown purpose. Could this truly be a random cosmic event, or is it the beginning of a hidden plan set in motion by us? The search for the answer starts now. On September 12th, 2025, the S-SWAN instrument aboard the SH spacecraft detected something that left astronomers astonished. A bright, fast-moving object was racing through our solar system, and data about it began pouring in almost immediately. Its tail stretched nearly 2.5 degrees across the sky, about 5 times wider than the full moon appears from Earth. A comet of that size is extremely uncommon upon discovery. Early observations measured it at magnitude 7.4, bright enough to be seen with small telescopes or even binoculars. News of the find spread quickly, and amateur astronomers rushed to confirm the satellite's data. In Australia, just 2 days after the initial report, someone captured a striking image of the object. A brilliant streak of light extended nearly beyond the edge of the camera's frame. By September 13th, the International Astronomical Union had officially designated it C/2025R2, adding SW to indicate the instrument that first detected it. Soon, professionals and amateurs around the world were tracking its progress, exchanging images and brightness measurements as excitement grew. Its enormous size and unusual brightness led to endless speculation. Most comets discovered today are faint and require powerful telescopes to detect, but SW was visible to almost anyone who knew where to look. Its tail stretched dramatically across the Virgo constellation and continued to brighten as it moved closer to the sun. At first, observers were not just amazed, they were stunned. This was clearly more than a typical icy visitor from the outer solar system. The data coming in showed readings unlike anything seen in recent memory. As studies continued, it became clear that SWAN was influencing the inner solar system in a way not witnessed since Hale-Bopp, or perhaps even earlier. Amateur astronomers, often the first to notice sudden changes in brightness or unusual behavior, began debating what could be causing such an immense and brilliant tail. For now, the object was too large, too bright, and too fast-moving to ignore. As telescopes around the world tracked its progress, the central question shifted from what this object was to why it was arriving now, and whether its appearance marked the beginning of something much larger. C/2025R2, now widely known as SWAN, wasn't the only new arrival capturing attention that October. Just days before SWAN was detected, another object, 3I/Atlas, had also been spotted. It was coming from an entirely different region of the sky. SWAN's trajectory traced back through the Aquarius constellation, while Atlas approached from the direction of Sagittarius. On a star map, the paths of these two objects are widely separated, spanning more than a quarter of the visible sky. Yet despite this distance, both will reach their closest point to the sun, their perihelion, within the same 10-day window. SWAN will do so around October 20th, coming within roughly 150 million kilometers of the sun. For the Atlas comet, the closest approach occurs on October 17th, just 3 days earlier, when it will pass at about 203 million kilometers. This means their perihelia are separated by only about 50 million kilometers, a smaller gap than the minimum distance between Earth and Mars. It isn't only the closeness of these dates that stands out. Their motion through space is also unusual. SWAN's orbit is tilted at more than 60 degrees relative to the plane in which the planets orbit, while Atlas follows a path that is almost perpendicular to it. The fact that their orbits are so dramatically different makes it extremely improbable that they would both enter the inner solar system nearly simultaneously and at such similar distances from the sun by chance alone. Typically, long-period comets and interstellar objects appear randomly throughout the year, with their perihelia occurring months or even years apart. Yet now, the two brightest recently discovered comets are approaching the sun almost at the same time, from opposite directions. The timing adds another layer of mystery. When SWAN and Atlas are at their closest, Earth-based telescopes will have difficulty observing them because the sun's glare will obscure the view from October 8th to 18th. precisely when the most revealing activity could occur. This means we won't be able to observe what happens as both objects reach their closest approach to the sun and to each other, because the sun's intense brightness will block our view. It's remarkable that two comets coming from such distant regions of space are arriving near the sun at nearly the same time and distance, especially during the one period when direct observation is impossible. The odds of this occurring by coincidence seem extremely small. In terms of orbital dynamics, it's like a narrow corridor, a tiny window in both space and time where the two objects converge. Whether this alignment is pure chance, an unknown link, or something intentional is uncertain, but the pattern itself is enough to make even skeptical scientists pause. 3 Atlas first drew attention not because it was particularly bright, but because it didn't behave like typical comets. Early analyses from the Atlas research team revealed something troubling. The object was composed mostly of nickel, with almost no iron detected. This contradicts what we know about comets, which usually show a combination of both elements in their gaseous emissions. The result was so unexpected that several labs requested the data be rechecked. Disagreements over the calibration of the instruments soon became public, prompting additional independent reviews. The debate only intensified with the next round of measurements. Instead of producing mostly water vapor, 3I/Atlas released 5 times more carbon dioxide than water. The CO2 signature was consistently strong in all observations, while water was barely present. It's unusual, but not impossible, for comets from extremely cold regions to behave this way. However, the activity of Atlas's tail was far more difficult to explain. Observers noticed a repeating pattern as it traveled. The comet accelerated 3 separate times, roughly 2 weeks apart, and with each acceleration, the color of its tail shifted dramatically. The first sudden increase in speed was recorded on July 29th, followed by another on August 14th. Images showed that during these events, the comet brightened rapidly, with its tail changing from a deep red to a pale gray before returning to its original hue. These bursts didn't resemble the gradual effects caused by solar heating. Instead, they happened abruptly and then faded, as if Atlas had fired some kind of propulsion system. Skeptics questioned the findings, suggesting possible calibration errors or unnoticed systemic mistakes. Yet the Atlas Spec lab team defended their data, stating that the timing and intensity of the signals were consistent across multiple observatories, from the Ibero Tracker network to Bill Gray's extensive telescope array. The measurements didn't align with typical gas release behavior. The composition of the tail's carbon dioxide appeared to shift with each burst of acceleration, a change some researchers referred to as an alteration in thrust mixture. What fueled further speculation was the energy calculation. If the recorded increases in speed were genuine, the internal power source required would need to generate around 10 gigawatts, roughly equivalent to the output of 10 large nuclear power plants. This level of power is far beyond what any known comet nucleus can generate. Most scientists still believe that natural explanations can account for much of the observed data, but unanswered questions, especially the unusual nickel emission spectrum and the repeated bursts of acceleration, continue to leave open the possibility that Atlas might be something constructed. For now, the mystery remains unsolved, and each new set of observations only deepens both skepticism and speculation. C/2025 R2, now called SWAN, is equally remarkable. Data confirms it, a tail stretching 2.5 degrees, a peak brightness rivaling the most brilliant comets seen in the last century, and a nucleus that may be producing an estimated 10,000 gigawatts of energy. That output exceeds the total energy generation of Earth's entire power grid. But it isn't just SWAN's immense size that has captured attention. Reports from several astronomers suggest that the object may be shielded or powered in ways that don't align with our current understanding of physics. The first clue came from how it reflected sunlight. Normally, a comet's nucleus scatters light in a diffuse pattern, but SWAN's core reflected it like polished metal. Some amateur observers even described its appearance as resembling nickel or a nickel-cobalt alloy, materials prized on Earth for their strength and resistance to corrosion. The theory of a nickel-cobalt shell began circulating widely online after SWAN showed no signs of breaking apart or dimming as it moved closer to the sun. Observers then reported an unusual shimmering halo surrounding it, shifting in brightness and shape. Some described it as resembling a plasma field, possibly a protective barrier shielding it from solar radiation and debris. This led to its nickname, the Fortress. While 3I/Atlas behaved behaves like a swift and agile drone, Swan seems more like an armored tank, slow, resilient, and seemingly indestructible. Its immense tail emits brief, concentrated bursts of energy that defy conventional explanations. Detailed light analyses reveal tiny, precise shifts in the tail's orientation, almost as if controlled bursts of plasma were steering or stabilizing it. Each of these bursts coincides with subtle brightness changes, occurring with regular timing, too structured to be dismissed as random surface activity. Its orbit adds even more intrigue. Swan completes a journey around the sun once every 22,554 years, a timescale that aligns closely with the end of the last ice age. The implications of this are profound. If Swan was created, it has been on its trajectory long before humanity ever existed, yet now it appears here, alongside Atlas, in the same region of space near the sun, precisely during a period when direct observation is nearly impossible. The odds of all these factors aligning by chance are vanishingly small. All of this suggests Swan is far more than an ordinary comet. Its extraordinary brightness, potential protective field, possible metallic shell, and staggering energy output make it the most significant object to enter our solar system in modern history. Whether it is a probe, a vessel, or something entirely different, Swan's arrival is forcing scientists to reconsider long-held assumptions and confront ideas once confined to science fiction. All the unusual details about Swan and 3I/Atlas have shifted the question from what are they to what might they be doing, when two enormous objects, one returning every 22,554 years and another potentially originating from a distant star system, appear in the same region of space at nearly the same time. It's hard to believe it's just coincidence. Their timing, positions, and the period when they disappeared from view have sparked numerous theories about their purpose. One of the more conventional explanations is that this is part of a planned operation, like something like refueling or maintenance. In this scenario, the sun acts as a kind of cosmic refueling station. Both objects could be designed to use its energy or magnetic fields to recharge, exchange data, or run system diagnostics. This idea isn't far-fetched in space exploration terms. Spacecraft often pass near the sun to gain speed from its gravity or collect additional energy. If Swan and Atlas are probes, then the sun would be an ideal location for recharging or communicating. But there are also more dramatic possibilities. Their close approach could be part of a repair effort, intercepting or retrieving a malfunctioning object, or even a confrontation between two entities with conflicting goals. The estimated power levels, roughly 10 gigawatts for Atlas and an immense 10,000 for Swan, imply that they are capable of active maneuvering rather than simply drifting. Atlas's bursts of acceleration and tail changes, along with Swan's controlled energy pulses, point to deliberate navigation, behavior more consistent with a mission than with random outgassing. Think about the possibility of an observation chain. Oumuamua in 2017, followed by Atlas, and now Swan, could all be part of a sequence responding to the radio signals Earth has been transmitting for over a century. Each successive visitor might represent a more sophisticated probe, designed to observe, gather data, or establish deeper contact. In these scenarios, the sun isn't just a backdrop. It's the central hub where they draw energy, rendezvous, and potentially use as a communication point. This evidence doesn't settle the debate, but it raises a deeper question. If this is part of a deliberate mission, what is the objective? A 22,554-year orbit is more than just an astronomical number. It's a recurring pattern that reaches back to the end of the last ice age, a time when Earth was a radically different place. Around 20,000 BCE, vast ice sheets blanketed much of the northern hemisphere, and dramatic climate shifts were reshaping the conditions that would eventually lead to human civilization. That era also left its mark in the geological record. Ice cores from Greenland and Antarctica show layers of dust and subtle chemical changes, signs of sudden and possibly cosmic events. These traces hint that something significant may have happened in the skies back then, something that might now be repeating. One focal point for this idea is Göbekli Tepe, an archaeological site in modern-day Turkey that's more than 11,000 years old. Its towering stone pillars are decorated with carvings of animals and mysterious symbols, which some researchers believe represent astronomical events, perhaps even the paths of comets. Some go further, suggesting the carvings depict cycles so long that they might even mark the return of objects like Swan. Still, many experts remain skeptical. Archaeologists and astronomers argue that these interpretations rely heavily on speculation and coincidence. The debate continues, with critics pointing out that there's no definitive evidence evidence linking ancient structures like Göbekli Tepe to specific celestial events. It's hard to ignore how perfectly the timing seems to line up. If Swan truly makes its return once every 22,554 years, then the last time it swept through the inner solar system would have been during a pivotal era, when the great ice sheets were retreating, when early humans first began building enduring structures and turning their eyes upward to chart the stars. Whether this is simply a coincidence or part of a deeper pattern that we don't yet understand is impossible to say, but that connection between a celestial visitor and humanity's earliest attempts to understand the cosmos lends the event an almost mythic quality, as if this object isn't just wandering through space, but weaving in and out of the story of human existence itself. Yet Swan's story is about more than just orbital mathematics or trajectories plotted on star charts. It hints at something larger, that rare cosmic travelers like Swan have always been part of humanity's story, present at the turning points that define civilizations. And now, as we wait for its reappearance, the circumstances surrounding its return have become even stranger. From October 8th to 18th, every major ground-based observatory will be shut down. The official explanation is maintenance, a period of downtime needed for solar realignment, but beneath that simple reason, quieter and more restrictive measures are being taken. Leaked internal communications from Space Command in the United States and the European Space Agency revealed strict instructions. Personnel were to stop using high-resolution cameras and radar instruments to observe Swan or 3Y/Atlas while they were obscured behind the sun. Even creative proposals to monitor them through indirect methods were quietly rejected, often without explanation. Requests to review the original observational data were either delayed indefinitely or quietly altered, leaving many researchers frustrated and suspicious. Meanwhile, some telescope schedulers, speaking cautiously and only off the record, claimed they had been directly instructed to avoid any public discussion of Swan and Atlas until after their closest approach to the sun. This sudden, coordinated silence created what many described as an enforced blackout, timed precisely to coincide with the two enigmatic objects slipping behind the solar glare. During this critical window, the only ongoing observations came not from billion-dollar institutions, but from a scattered network of independent astronomers and dedicated hobbyists determined to keep watch. When the directive to sever communications came down, official agencies went quiet almost immediately, but the amateur community did not. Bill Gray, a veteran orbital analyst renowned for his public data sharing, stepped into the void. He began organizing a vast network of enthusiasts and small observatories, using both public forums and private channels to coordinate observations and share findings. It was a grassroots effort driven by curiosity and defiance, a reminder that even when powerful institutions fall silent, the pursuit of knowledge does not have to stop. Keep your eyes fixed on the night sky, watch for every flicker, every unusual movement, and make sure you document it all before those fleeting moments vanish. Then share what you find with others, because once the information is gone, it may never return. Across Spain and Portugal, the Ibero Tracker Collective took this idea to heart, pooling together the observations from their broad field sensors to create a clearer picture of what was happening above. At the same time, smaller private astronomy groups began hinting at covert projects, plans to bypass the official blackout using improvised radio arrays, repurposed antennas, and even aging weather satellites that most had long forgotten. With government agencies refusing to release updates and many of the major observatories shuttered without warning, this grassroots network of volunteers became the only lifeline for anyone seeking answers. People from all walks of life, amateur stargazers, radio enthusiasts, or simply those with a spare laptop and access to free orbital tracking software, were suddenly able to contribute to a global effort. It was more than just a workaround to a problem. It was a call to action born of necessity, a collective refusal to accept silence where curiosity demanded knowledge. In many ways, this moment felt like an invitation, an urgent plea for help. To piece together the truth, one now had to become a detective, gathering fragments of evidence scattered across the sky. If the mysterious visitors known as Swan and Atlas ever return, it may not be a professional astronomer who first notices, but rather an ordinary observer carefully scanning the heavens from their backyard. History suggests this is not far-fetched. After all, the odds of two unidentified objects entering our solar system simultaneously were astronomically low, and yet it happened. Their arrival sparked questions that no official source has yet answered, leaving the task of uncovering the truth to those willing to search for it themselves.